Hey, it's time to read 3 random pages out of my modern refrigeration and air conditioning book. All right, we're going in the middle. Here we go. It applies pressure to the diaphragm or bladder and compresses the air. When the temperature of the water drops and the water contracts, the air surrounding the bladder or on the other side of the diaphragm expands, expelling some of the water back into the system. This helps maintain a stable system pressure under varying operating conditions. Many bladder and diaphragm expansion tanks are equipped with an air fitting that can be used to pump air into the tank to adjust the system pressure. Others are pre-charged to 12 psi at the factory and cannot be recharged or adjusted. Caution: charging an expansion tank. Extreme care should be used if air is added to a diaphragm or bladder expansion tank. Excessive air pressure can rupture the diaphragm or bladder. Never use an air compressor or compressed air tank to add air to an expansion tank. Only use a bicycle pump and check the pressure in the expansion tank frequently. In older expansion tank designs, there is no physical barrier between the water and the air. These older expansion tanks are horizontally oriented to provide a larger airspace above the water reservoir. They are also considerably larger than diaphragm or bladder expansion tanks. The older style expansion tanks are always mounted above the boiler, such as in the attic or between floor joists. They are typically equipped with a combination valve at the bottom of the tank. The combination valve allows water to be drained from the tank and allows air to enter the tank at the same time. An expansion tank can be mounted on either the supply or return side of the system. However, it is vitally important that the circulating pump circulates water away from the expansion tank rather than toward the tank. Valves. A hydronic system requires numerous valves to function properly. These valves control the flow of water through the system. Some of the valves commonly... Okay, that's one page. That's a page. Okay, flipping to another page. Aquastat. An aquastat measures the temperature of the boiler water and turns the burner or heating element on and off as needed to maintain the preset temperature. Many aquastats have a built-in safety function that shuts off the burner or heating element if the water temperature in the boiler exceeds the safe operating limit. The aquastat may need to be reset manually before the boiler can be operated again. An aquastat also sets a boiler's low operating temperature and differential. These settings determine a boiler's operating temperature range. The aquastat turns on the burner or heating element if the boiler's water temperature drops below the operating temperature range and turns it off again when the temperature exceeds the operating temperature range. Room thermostat. While an aquastat maintains the proper water temperature in the boiler, a variety of thermostatic controls can be used to maintain the desired temperature in the conditioned space. One type of thermostatic control, called a room thermostat, adjusts room temperature by regulating the flow of heated water throughout the system. In a series loop system, the room thermostat turns the circulating pump on and off as needed to maintain the desired temperature in the conditioned space. In one pipe and two pipe systems, reduced flow through one terminal unit does not result in reduced flow through the other terminal units, as would be the case in a series loop. This means that while a main room thermostat can be used to set an overall heat level for the building, individual thermostatic valves can be installed to control flow through each individual terminal unit. This allows greater control of heat in specific areas. For zone systems, separate room thermostats can be installed in each zone. Each thermostat provides an... That's another page. Solar DHW systems are designed to supply from 40% to 75% of the required hot water for a home. Auxiliary heating supplies the final heat to reach the temperature required, typically 120 degrees Fahrenheit to 140 degrees Fahrenheit. Pro tip: sizing solar DHW systems. Domestic hot water use is approximately 25 gallons per day for each person in a family. Solar collector sizes range from half a square foot to 2 square feet per gallon of hot water required per day, depending on location. In a 2-tank system, the solar water's heater storage tank is usually half as large as the storage tank of the conventional water heater. Solar heating for pools, hot tubs, and spas. Heating the water in swimming pools can be used to extend the swimming season in many areas. The solar heating system for a swimming pool can be as simple and inexpensive as a set of black plastic bags placed in the pool. The black bags absorb the heat from the sun and transfer it directly to the pool. In warm climates, solar pool heaters may be of very simple design because no storage is required and no freezing protection is necessary. Also, the collector does not need to withstand water pressure as high as that required for space or domestic water heating systems. These pool heaters require only a low-pressure pump, solar collectors, and piping. The pump circulates pool water from the pool to the solar collectors, where it is heated. The warmed pool water is then piped back to the pool. In cold climates, a secondary loop and heat exchanger are required. The heating system uses an antifreeze solution. This antifreeze solution is circulated by a pump from the pool heat exchanger to the solar collector. The warmed solution then passes from the collector to the heat exchanger. The solution transfers its heat to the pool water running through the heat exchanger and back to the pool. The size of a solar collector for a pool heater is approximately half of the pool surface area. This provides good spring and fall heating. The required water temperature for pools is only about 80 degrees Fahrenheit, 27 degrees Celsius. Due to this relatively low temperature, the efficiency of solar pool heaters can be as great as 70 to 80%. Solar heating systems may also be used to heat the water in hot tubs and spas. Some newer systems also include a filter and an inline sterilizer that exposes the water to an intense ultraviolet light source. These items can be helpful in keeping harmful bacteria and mildew out of the spa. Damp environment of the warm, damp environment of the hot tub or spa. Thinking green. Pool covers. Covering a pool or hot tub when it is not in use can reduce heat loss, which in turn reduces the amount of energy needed to maintain the proper pool temperature. Supplementary heat. In any location, there may be times when the sun does not supply enough heat energy to the collector. In such cases, supplementary heat must be supplied. Electric resistance heating, or gas or oil burner, or heat pump may be used. As described earlier in this chapter, in 2-tank DHW systems, the water is preheated by solar energy. It is then heated by a supplementary heater to the desired temperature. Electric heating. Electric resistance heating is one form of heating used to supplement solar heat. With an air-based heating system, a direct electric resistance radiator may be installed in the air duct. A thermostat is used to control the amount of electric heat needed. In a liquid-based space heating system, an electric heating element can be installed in an auxiliary tank. It provides supplementary heating when the heat stored in the main tank is exhausted. In some cases, individual room resistance heating radiators may be installed. However, these tend to be expensive if they are used for more than a few hours. Oil and gas heating. If oil or gas is used for supplementary heating, a separate furnace is installed. This is shown in Figure 39. A thermostat turns on the burner in the furnace when heat from the solar source is not enough to heat the conditioned space to the desired temperature. In liquid-based systems that use radiators, burners may be used to heat the water in an auxiliary tank. Heat pumps.
In many areas, a heat pump is one of the most efficient methods of supplemental solar heat. The heat pump is well suited for use with solar heat. A heat pump can also function as an air conditioning system to remove heat. A heat pump transfers heat like... Okay, that's 3 pages. Thank you for tuning in. Hopefully I'll see you tomorrow. Wow.